So this is question 7 from part D, the second part of part D. So it says, what is the temperature of 34.2 grams of sulfur dioxide occupying 30 liters of space having a pressure of 800 torr? So the main thing that we have to look at first is figure out which equation we're going to use. Is it going to be the combined gas law or is it going to be the ideal gas law? So for this one, since it gives us grams, the combined gas law only has pressure, volume, and temperature, so that means this one is going to have to be the ideal gas law. PV equals nRT per nert. So let's go ahead and write out those variables. So P, pressure, torr is our pressure, so 800 torr. Our volume is 30 liters. N is number of moles, but at no point does it actually give us the number of moles here. But what it does give us is the number of grams, and we can convert grams to moles. So we're going to start off with 34.2 grams sulfur dioxide. So it's a covalent compound, so it is sulfur. That prefix di meaning 2 with oxide, SO2. Our R is our gas constant, so 0.0821 liters ATM per Kelvin mole. And the temperature is what we're trying to find. So that's our unknown. So before we can get started and plugging it in and getting it all plugged and chugged out, we got to do a couple conversions. So the two we have to go from torr to ATM, and we have to go from grams to moles. The reason we have to do both of those is because in our gas constant, it tells us all the units we have to have. So we don't have torr, we have ATM, and we don't have grams, we have moles. So let's go ahead and do those conversions. So 800 torr. Torr up top means it's going to the bottom. And then we're going to ATM. If you check your notes or other videos, you should have these conversions. But it's 1 ATM is equal to 760 torr. So let's go ahead and plug that in. 800 divided by 760. And we get that this is equal to 1.05 ATM. Again, let's rewrite that. Keep everything nice and clear. Our next spot is we have to convert those grams. So let's go ahead and start off with 34.2 grams of sulfur dioxide. We're converting it to moles. So grams up top means it goes to the bottom. Up top is going to be moles of SO2. So this, if you're looking at mole island, this is one of those little tiny bridges. So for this, moles always gets 1. And then we find the molar mass of sulfur dioxide. So we check our periodic table. And we see sulfur is 32.0, we can round it to 7. So 32.07 plus 2 oxygens, each with a molar mass of 16. And we get the molar mass of sulfur dioxide to be 64.07. So let's go ahead and do that math. So 34.2 times 1 divided by 64.07. And we get 0.534 moles of SO2. So again, anytime you're going to moles, I suggest you go out to the thousandth of a mole, because again, this is a huge unit, so you really want it to be as precise as possible. And then we can rewrite it, 0.534 moles. And now we have everything in that unit we need, so we're just going to plug it right on in and get started. So PV equals nRT. The last thing I'm going to do before I plug it all in is I know I'm solving for T, so I'm going to go ahead and isolate that variable before I start plugging everything in. So I'm going to divide both sides by N and R. That way it cancels. Let's go ahead and rewrite that. So PV over NR is equal to T. So our pressure, 1.05 ATM over our volume, 30.0 liters, over the number of moles, 0.534, the universal gas constant. And that is equal to our temperature. So let's go ahead and plug that in. The big thing with this is make sure you're always using those parentheses. So open up those parentheses to plug in the top. 1.05 times 30. Close parentheses, there's our whole top. Divided by, open up those parentheses for the bottom. 0.534 0.34 times 0.0821, our gas constant, close parentheses for the bottom, hit enter, and we get our temperature is 718.50 Kelvin. So keep in mind your temperature is always going to come out in Kelvin. Another way you can check this is if you look to your universal gas constant, boom, Kelvin for the temperature. The other way is if you look at your units through the problem, all of them are going to cancel except your unit of temperature. So ATM to ATM, mole to mole, and liter to liter, leaving you with Kelvin. Awesome.